Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to optics in the chapters of lenses and formation of images. This exercise was a previous one in the Brevet exams in 2013, first session, first exercise. The title of this exercise is Converging Glance. Consider a converging glance L of focal length f is equal to 4 centimeters and an object AB placed perpendicular to the optical axis of L as shown in the figure below. So they mentioned the figure, so now I can use it. F represents the object focus of L and F prime is its image focus. So number one, they are telling me that O is the optical center of L, justify. So if you look at the figure, we can notice that the point O represents the intersection of the optical axis and the lens L. For this reason, O is the optical center. So let's write down that O is the optical center. Because it is the intersection between the optical axis and the lens L. Now in number 2 they are telling me to determine the size of the object AB and its distance D from L. So let's start by calculating the size of the object. Now AB consists of 1 to 2 divisions, and we multiply by the scale along which we have counted the number of divisions, which is scale along the y-axis. This will give me 4. Since the scale is in centimeters, then the value of AB will be in centimeter. Always, all quantities in physics must have unit. And finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. And now let's calculate the distance D between AB and L. So distance between AB and L. Now this distance is denoted by D. So this is the object AB and this is the lens L. This distance consists of 1, 2, 3, 4, 5, 6 divisions. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. This will give me 12. Since the scale is in centimeters, then the value of D will be in centimeters. So D is equal to 12 centimeters. Okay. This is it for part 2. Now in part 3 they are telling me redraw the figure below on the graph paper using the same scale. Okay, so notice that here the direction of propagation of light is from left to right, and whenever we need to redraw we always start by drawing the optical axis at the center, having the same direction of propagation of light, which is from left to right. Okay, and this is the optical axis x prime x. Then we place the lens L perpendicular to the optical axis at the center, and the intersection between the optical axis and the lens L is the optical center O. And now let's place the object focus and the image focus. They are away from the lens 2 divisions, in which F is 2 divisions in front of the lens. So 1, 2, this is F. And F prime is the symmetric of F with respect to O. Now the point A is located 1, 2, 3, 4, 5, 6 divisions in front of the lens on the optical axis. So 1, 2, 3, 4, 5, 6. This is the point A. And the point B is located 1 to 2 divisions above A hat is found on B. Now let's trace the object AB. The point I is located 2 divisions on the lens upward. This is the point I, and this is the lens L. And BI is an incident luminous ray issued from B parallel to the optical axis. Moreover, the scale is given by 2 centimeters along the x-axis and 2 centimeters along the y-axis. So this is the redrawing. Now in 4 part A, they are telling me complete on the figure the path of the particular ray BI and justify. So we need to trace and justify the path of the ray BI. So let's do the tracing first. Notice that BI is an incident luminous ray parallel to the optical axis, and we know that always incident parallel ray is related to the image focus. Therefore, this ray will emerge passing through the image focus like this. And we don't forget arrows on emergent rays that indicate the direction of propagation of light. Now let's do the justification. An incident ray issued from B parallel to the optical axis emerges passing through the image focus. And now in part B, they are telling me trace the path of another particular ray issued from B and incident on L. So they didn't specify which ray I should draw, okay? So here we have 2 choices, either one passing through the optical center or passing through the object focus. So we'll consider the one passing through the optical center. They told me trace, so no need to justify. This is an incident ray issued from B passing through the optical center. We know that it will emerge without deviation, and we don't forget arrows on light rays. Okay, so done for part B. Okay, so now we have reached part C. In part C, they are telling me construct using the above 2 rays the image A prime B prime of AB. And the word construct means that we need to trace and justify at the same time. So we have already traced the emergent rays, and always the intersection of the emergent rays is the image of the object. So this is the point of intersection of the emergent rays. So this is the image of which object. Notice that these 2 emergent rays are coming from these incident rays that are coming from the point B. Therefore, their point of intersection will be the image B prime of B. Moreover, a hat is found on B directed away from the optical axis like this. Then we must place a hat on B prime directed away from the optical axis like this. Let's place the hat. Okay, so now we have traced B prime. Now we need to trace A prime. Notice that the point A represents the foot perpendicular of B on the optical axis. Then A prime will represent the foot perpendicular of B prime on the optical axis. And now let's trace the image A prime B prime. So this is the tracing of the image. Now let's do the justification. So what does the point B represent? Then the image B prime of B is the intersection of the emergent rays. So now we have justified the tracing of B prime. It's left to justify the tracing of A prime. What does A prime represent? and A prime is the foot perpendicular of B prime on the optical axis. Okay, so now in part D they are telling me specify the nature of the image A prime B prime. So in other words, we need to specify whether the obtained image is real or virtual. So part D, okay, so notice that here the object AB is pointing upward and the image A prime B prime is pointing downward, which means that the image is inverted, is in an opposite direction with respect to the object, which means it is inverted. And we know that whenever the image is inverted with respect to the object, then the image is real. So let's say that since it is inverted with respect to the object AB, then the image A prime B prime is real. One could give another reason why the image is real. Notice that the object AB is in front of the lens and the image A prime B prime is behind the lens, and whenever the image and the object are on opposite sides of the lens, this means that the image is real. Okay, since the object AB and the image A prime B prime are on opposite sides, this means that the image A prime B prime is real. And now in part E they are telling me to determine the size of the image A prime B prime. Okay, size of the image A prime B prime. Now A prime B prime consists of one division, and we multiply by the scale along which we have counted the number of divisions, which is scale along the y-axis. This will give me 2 centimeters. So A prime B prime is equal to 2 centimeters. And now in part 5 they are telling me that A prime B prime is obtained clearly on screen E. Okay, determine the distance D prime between L and E. So in part 5 we are determining the distance between L and E. This distance is denoted by D prime. Now because the image A prime B prime is obtained on the screen E, so the distance between L and E represent the distance between the lens and the image, and this distance D prime consists of 3 divisions, and we multiply by the scale along which I have counted the number of divisions, which is scale along the x-axis. So this will give us 6 centimeters. So D prime is equal to 6 centimeters. And by this we have finished solving this exercise. I hope it was beneficial for you guys out there watching it, and see you soon in another one.